Good afternoon, and thanks for coming again. We had some questions from our graduate students who are in service, student teaching, and they wanted to know a little bit more about Algebra Project curriculum and what makes it uniquely suited for students in New York City. What aspects of it?
So actually, I don't think of it as something that's uniquely suited for students in New York. I mean, I think that the Algebra Project's contribution to the teaching and learning of math really revolves around what I think of as the marriage of two historical traditions around learning and teaching. So one is sort of more widely known, and that's experiential learning. And in my mind, that traces back to the end of the 19th century, the beginning of the 20th century with Piaget and Dewey. And then Lewin is another name in that constellation. So I think progressive education sort of adopted experiential learning in the early part of the 20th century, at least through the early grades, particularly as far as math was concerned. I think it got adopted at higher grade levels around social science and maybe history. So there the idea was that at 12 o'clock there was something that happened. You could dress it up and call it an event. And then at 15:15 there was something that was thought about around what happened, right? And you could dress that up and call it your reflection on the event, right? And then at 30:30 there was the development of some abstraction, some abstract concept based on what you thought about what happened, right? And then at 2:15, there was the idea of using what you had thought about to change something in what had happened, right? So there was, if you think about cooking, you're designing a meal, you think about it, and then at 30:30 you decide to make some changes in your recipe. So at 2:45 you got a different recipe, right? So a lot of what we learn in that mode, and it was dressed up with Lewin with the model. So you had the event, the reflection, the abstraction, and the application of that in that model. And that was incorporated into math classes, at least in the early grades, probably up to at least grade 3, Cuisenaire rods and other kinds of things like that. But then in grade 4 you got division and long division. And I like to think you got purple ditto sheets along with that, right? I mean, they kind of dropped. It wasn't really clear how to use this model as you got more complicated math. And so there wasn't, and so the other way I think about what happened is that the battle between Hilbert and Frege really was won by Hilbert. Throughout the 20th century. So Frege writes, Hilbert, I guess, starts, and the question is about the axioms of geometry. And Frege writes and says that to Hilbert that the axioms of geometry are consistent because they are true. And then Hilbert writes back and says, well, for all of my mathematical career, I've said the opposite. The axioms of geometry are true because they are consistent, right? So I think what we got in the 20th century was the elaboration of Hilbert's idea in the teaching of math about consistency, right? So you have certain axioms for school mathematics, and they hang together. But the idea that students should actually have, and this gets me into the second part, Quine, who was the star of Harvard's philosophy department in the 50s, was also a mathematical logician as well as a philosopher of math. And he was looking for what he termed mathematical truth. That is, he wanted to actually lay the foundation for truth in mathematics. And what Quine said was that mathematics gets off the ground by what he called the regimentation of ordinary discourse. So the languages that people just speak all over get what he said regimented. It's like you straitjacket them. And he said you get a conceptual language that nobody speaks, but which is underpinning the symbolic representations of scientific discourse. Right? So Quine located a lot of meaning in the idea of an observation sentence, the idea that we can all ground our scientific truths. I mean, the big observation sentence of the 20th century was when editing went out into the desert to test Einstein's hypothesis about whether or not light was going to bend as it passed the star, right? And so they made an observation, right, and they came to an agreement about what they saw, right? So for Quine, those kind of statements were what grounded, scientific theory, but he also said they grounded math, right? And so the issue of the more complex math and this idea of experiential learning got lost with Hilbert's idea of consistency. So you weren't looking for the entry-level observation statements for students to access to ground their mathematical theories, right, that you're asking them to develop. And so we got a lot of focus on various procedures, which are really grounded in the idea of consistency, right? So if you do this and do this and do this, you don't run into trouble, right? But you also don't look for what the denotation is, what the meaning is of those symbols, right? And you don't look for observations that can be made that ground, and you don't look for truth in that sense, right? So everything kind of hangs together, right? So what the Algebra Project has done is taken Quine's idea, and Quine, I mean, he is part of a legacy. You can trace this issue back through 19th century math. You can look in the letters that Gauss is writing to other mathematicians and criticizing them for just playing the game, right, of manipulating symbols, dealing with the cloth as opposed to looking for, it's the clothing, not the real mathematical concepts that are being dealt with here, right? And so you get this debate through the history of math, and it's never really decided, right? It's not something that people say, oh, this is really right and this is not right, but it's there. And so Quine is taking a stance in that legacy, and what we did was marry his idea from that legacy with experiential learning. So between the time of the reflection at quarter past and the abstraction, we inserted the idea, well, what we need to do is look at the language, the observations that have been made about the event, and figure out how to introduce the students into ways to regiment that language, right? To straitjacket it, get it ready for mathematical representations. So I think that's been our initial insight. And then the mathematicians who've been working with us have taken that and, taken it this way and that way, right? Because they don't all agree about how this should be done or what the ways to do it. But at least there's a kind of playing field there that this is something that really needs we need to pay close attention to. The issue of, well, we're going to agree to start with an event. There's got to be a common experience that the students have. And then after they have that, we're going to agree that we need to process their language and come to the place where they actually are representing this event in a way in which it can be translated into the standard mathematical language. So I don't think that that's unique for New York, right? But I think because I think that it's really trying to say, look, anybody on the planet can access the ordinary events of their daily lives and use those to generate some mathematical understanding.
Okay. So going back to this idea around the mathematical language and literacy, one of our students posed a question. What are the practices of Algebra Project that and strategies that can be used or that are part of the project curriculum that really promote literacy for math students?
Right. So I think one practice is that students should talk about and write about the event. And so they should talk and write about the event in their own language and about what they know is true because they experienced it. So now typically students do not think they're doing math when they do that. And so the next step is the introduction of the features of the event that you want to mathematize. Now also typically those are features that students do not think are important enough to actually mention. And this is a big issue with math because math really, even the Hilbert program, right? So what's the Hilbert program? The Hilbert program is start with what is obvious and proceed by steps that are obvious to arrive at something that's not obvious, right? But to ask a student to pay attention to what is obvious is, well, why should I pay attention to it if it's obvious? So that's the first hurdle, right? That math deals in some sense with what is universal and obvious. And so to get students to pay attention is one of the first things that you have to really work on, right? And so, but getting students to actually pay attention to things that they see and experience every day and decide that they're going to attend to these is part of what the Algebra Project, if you're thinking about a strategy, right? So the strategy is getting students to pay attention to things that are obvious, right? So how teachers decide to do that and how it gets done in different settings. There are different ways that teachers are using to do that, but at least one of the things that this way of approaching the math does is allows the students to put that on the table, that this is important, right? And it also allows them universal access because they all can do that, right? The question is whether they think it's important to do it. And so how you foreground the importance of this is one of the big challenges of the Algebra Project. So then the next, I think, is getting them to actually enter into a dialogue with each other and with the teacher about the features that you actually want to mathematize, right? And getting them to focus on those features and how they would like to represent them. So there, you're trying to really nail down the idea that there's meaning in the symbols that you're going to create. You create the symbols. You attach meaning to those symbols. I mean, the idea is that they should use iconic language, picture language, to create their initial representations of these features. Once there's an agreement about what features are that you're going to actually focus on and mathematize, then you're asking the students to attach meaning to symbols that they create. So you want them to really understand that people create these symbols and they've decided to give meaning to these symbols, right? And you can do that. You have to do that if you're going to understand how mathematics grows and gets generated. So that's now that takes time, right? Because the students have to meet together, talk together. They have to produce some work. They have to put their work up in public in the classroom. They have to go around and look at it. They have to decide what this symbol really is saying or not saying, right? And so, again, that's a piece of the work that people are likely to think isn't really doing math, right? The students are likely to think that they're not really doing math. And the teachers are likely, certainly the teachers who have been trained in the Hilbert sense, where what's important is procedures and consistency and generating, a lot of different mathematical expressions that relate to each other and are equivalent in some way, they're not ready to see this as important work, right? So again, foregrounding the importance of that work, and actually getting students to think about that as, well, this is how scientific knowledge actually gets off the ground, not just in math, but in all of the scientific disciplines, right? So that's a second part of it, right? And then, so I think in doing that, what's important is the individual work, the discussions in their group that they've gotta. There has to be a classroom culture where students are comfortable and respectful enough of each other so that they're free to talk to each other and not afraid to put their ideas out because of being put down, right? So creating that classroom culture and then creating the idea that you publish what you say in your group in the class, right? That there's got to be, in Algebra Project classrooms, on the walls, the students' work, and the students have to be able to say, well, this is my work and this is what it means, right, to the whole class. So this idea of publishing out their work, that it's not something that happens on a piece of paper that you crumple up as soon as you've written it down and throw it away, right? There's something that you're creating that's going to be used later, right? And you have to take some responsibility for being able to say in public what it is that. So this business of actually the conversation of math in the classroom, how to generate that, in small groups, but also in whole class discussions that students actually are the center of. I mean, yes, you can have whole class discussions that the teacher is the center of, but the Algebra Project wants to push that. It wants to actually put the students in the center of whole class discussions. And the way to do that is they create something in their group, and then that group there's time taken to put that up, and then the group actually talks about that to the whole class, right? So it's those are sort of the tools to use in this, and the last step is the easiest, taking what has been created and saying, oh, well, this is how it looks in standard mathematical language, right?
Interesting. It sort of plays into the idea around expectations. That was another question or through our discussions, what might teachers expect, or how might they expect classrooms to look and feel different? That the expectations from students are very different from what they might see using a traditional curriculum.
Yeah, so this is probably the hardest part. And the teachers have to really want a different kind of classroom. I mean, if they're tied into the idea, well, at the beginning of the class for 5 minutes, I have to stand here and say what we did yesterday and what we're going to do today, and actually, kind of begin the class by conducting the class, and orchestrating the class. So it's hard for teachers, and even, with the standard lesson format, well, you have to have this on the board, which says this, and this, right? So there are other ways to start classes, right? But one of the hardest things is, can the class get to the point where the teacher actually can start the class by talking to individual groups of kids and moving around, just talking to kids about what it is that they're going to start to do, and the class actually has a culture where, one of the first things I had to try to establish when I was, at Lanier High School in Jackson was the idea, I'm not the police person in this class, right? And so I'm not looking to see who's doing what, right? I'm trying to have conversations with individual and groups of students all through the class about the work they're doing, right? That's my job. And so the question is whether this class, whether you all are going to allow that to actually happen and decide what your job is, right, in the class, right? Because you can think that your job is to cut as much slack as you can, right? And my job is to catch you cutting slack, right? So, unless you can turn that around, then the job of the teacher becomes, a lot of catching kids, right, cutting slack and doing stuff. And it doesn't mean that you're not sometimes saying, hey, to an individual student, right? But it does mean that there's you really are deciding that you're going to work to establish a different kind of culture in the class.
Is that back on camera, one specific?
Oh. You ready? Okay.
Okay. There are two more questions. One specific question from I say she's pre-service, but she has a lot of background with the Algebra Project and actually worked with your group in Brooklyn,
right? Okay.
Boys and girls, and she had questions around how does Algebra Project foster a freedom to problem solve in a way that is comfortable for students, but may provide some discomfort for instructors.
Right. So I guess one question is, if you have on the table a student's idea, which is, say, perpendicular to where you're trying to go, right? What do you do with it? Or what does the class do with it, right? And often there are ideas which are on the table which you can't handle right at that spot. So one strategy is to board it, right? Not to lose it, right? Because I think often what happens is students get ideas and concepts and they throw them out. You can't handle them right there, and then somehow they're dismissed, right? Or they're under. I was in a class up in the Bronx, right? And the students had an assignment. They had points on a circle. And their job was to describe in their own language the relation of one point to another, right? And so the group I was in, one of the students, there were two fellows in the group, both of whom had an initial idea about it, which was, okay, well, I'm at this point over here, and it was the point that if the center of the circle was 0, then that would be +1, right? And so it had a name, A, right? And they were going to go to a point B, which would be around, not at 12 o'clock on the clock, but around 1 o'clock or something. So they both had the idea of the first thing they should do was go to the center of the circle, right? And then one of the students, his idea was, well, once I get to the center, I'm going to turn, and he finally figured out which way he would turn. But he didn't turn to go right to B at 1 o'clock. He was going to turn sort of 90 degrees and go up to 12 o'clock, right? And once he got to 12 o'clock, he thought he could finish his turn, right, and get to 1 o'clock. But we talked some, and then he finally said, oh, well, I'll have to travel along the circle, right, to get back. So the other guy said, look, you start at this point A and you go to the center, and then what you do is you come back, and he called his a measurement procedure. He was going to measure the distance from the point A to the center, and then measure the distance back to the point where you were directly under B, and then measure the distance up to B, right? And this is how he was going to find out where B was relative to A, right? So he went up to present, and the teacher, she dropped what he said, right? And, you know, later they were going to look at the cosine of the angle and the sine of the angle. And so he had actually a process that would lead them into the idea of these two numbers, right? And so you had an opportunity for him and the class to actually investigate what he was doing and everybody, and to figure out how to name what he was doing and everything. So the question about, it's not exactly what you asked, but it's the idea that students actually have insights which are in some senses tangential or even perpendicular to where you're going. And if you can't figure out how to actually use them, then you really do lose what you're trying to gain, which is that, students have a way of getting into this subject which you might not have thought of at all, right? Because when I talked to the mathematician who had devised this, he hadn't thought that one of the ways students would respond would be by going to the center. He was thinking, oh, they're going to go around the circumference or do something like that, right? And I'm not sure why they thought of going to the center, but for them, the center of the circle was a very important place, right? And so they thought they should visit it in order to get to this other point, So it's stuff like that that I think is really, so there's a question, well, how do you prepare teachers so that, because they have to have a deeper insight into the math itself, but then they also have to be on the lookout. Right? There's a constant on the lookout and second guessing of, well, what really is, what really has happened here that could be used and exploited, right, in the classroom. So that isn't easy.
So that's leading into my next idea. How would a pre-service or in-service teacher, this again is a very different approach and a different kind of awareness in the classroom, how might they get more exposure to AP curriculum?
Yeah, so I've been doing something, and I've done it with the teachers at a AFT workshop, and we did it with some financiers at, I think, J.P. Morgan or something. They asked us, and I've done it in different settings now, and that is these numbers, right, and classifying them into 3 groups. So some are red, some are yellow, some are blue. And the question is, well, how would you classify numbers into 3 groups like that, so that you have a consistent way of saying, well, this is why these numbers are red and these numbers are blue and these are yellow, right? And to help them, we gave the number of numbers in cohorts. So we said, okay, from 2 to 10, these many are red, these many are yellow, these many are blue. And from 10 to 20, tell them which ones are red, yellow, and blue, but how many are red, yellow, and blue, right? So it's a real problem, right? And really interesting because the teachers couldn't solve it and were not sure they really wanted to work at solving it, right? Because on the one hand, these are very simple numbers, you know them, and so Hilbert kicks in because they start looking for complicated ways to think about, oh, there must be some really complicated formula here and it's just based on what is really very obvious, but and because it's obvious and you don't think about the numbers in this way, it's difficult to actually access, right? But so a problem like that, if you're giving it to teachers in small groups and they have to wrestle with this problem, they are put in the situation of the students, right, where they're giving problems to the students. And so the $64 issue is whether the teachers are willing to put themselves there and then actually figure out what they are thinking and go through this process, right, of publishing what they're thinking, actually making public what they're thinking, and not being afraid to do that, and not putting anybody down, right, for what they're thinking. So, because that's what you're asking for the students. You want access to what the students are thinking, right? You want to reverse the idea where, oh, the job of the students is to figure out what the teacher is thinking, right? And say, well, the real job of the teacher here is to get access to what the students are thinking, right? So, if we can't get them to be comfortable about getting access to what they think about problems like this, then we can't really get to first base. So I think that's one of the issues. How in the pre-service or in-service, how are things put so that teachers are really in this zone where there's some discomfort there, but there's got to be a culture around this discomfort. Namely, it's okay, right? This is what learning is, and this is how we share with each other, how we open up our minds about what we're thinking about this, you know.
So you would say teachers who are willing to put themselves in the position of students are the ones who are prime candidates for thinking about the Algebra Project curriculum?
Well, if we're thinking about what has to happen in the process of training, so that's part of it, but they also have to have, in the process of the professional development, they have to have a picture of how they function as teachers in a classroom, right? So part of the function of teachers in a classroom is understanding what the students are going through. So they have to understand that also with respect to in the process of this either in-service or pre-service. So there's a mix there. It's not all one or the other, right?